Hello everyone. Good morning, good evening, good afternoon. So this is Arul and Greg. Today we are going to see data warehousing in Microsoft Fabric, which we are able to help you to get certified in DP-700 to become a uh, Fabric data engineer. Yeah, so in the entire session, we'll be covering and helping you to understand the data warehousing and the DP-700 certification success guide. So that is what we are going to see. So yeah, yeah, a little bit about myself is I am a Power BI Microsoft Fabric super user. I've been using Power BI for more than 5 years and Microsoft Fabric since its inception. So that's a small intro about me. And yeah, over to you, Greg.
Yeah, so look, I'm Greg. So, hi, folks, for anyone who hasn't seen me in a previous session. So, I'm a long term data platform MVP and a member of the Microsoft Regional Director Program. I've got social links there to show you how to get in contact with me. I want to welcome our moderators. So, we've got Greg Nash, old buddy today, and Nandan Hedge. And so, look, they're going to be in the chat to answer questions for you. Where this session fits, this is session 4 in a series of 7 sessions. And so this one specifically is looking at data warehousing. And this series, of course, is the one for DP-700, but it's for people coming to this from scratch more so than the previous sessions you can see that were for people who've already done DP-203. So this is a more in-depth session than the previous sessions, this series. Look, I want to throw a mention too to MGM Grand, where the Fabric Community Conference will be. If I could be anywhere at the end of March, I'd really wish I could be there for this. Importantly, there's a code there, so MSCUST will get you a $150 discount for attending the show, and there's a registration link there, which again will show you towards the end of the show. One other thing I want to throw out is there's a Power BI Data Visualization World Championship. So if you think what it takes to create stunning, insightful, and accessible visualizations, so get ready to put your Power BI skills to the ultimate showdown. And so this runs for a few weeks, and the winners will be announced at the Microsoft Fabric Community Conference. If you're going to take exam DP-700, which I presume is the reason you're attending this session, there is an offer for a 50% discount for this. And so the link down the bottom, so AKMSGC DP-700, it is limited, but I gather there still seems to be plenty of that available at the moment. And I would expect it to go fairly quickly though too. I also want to mention that this is a live and interactive session, and we've got our moderators in the chat, and we'll check on questions periodically as well. And so don't just be shy. It'd be really good for you to say hi in the chat and let us know where you're from. And if you've got any questions, then fire away and just ask for those. But let's start off with an intro from Arul talking about data warehousing in Fabric.
Hey, thank Greg. So yeah, so again, welcome to this episode 4 of the getting certified in DP-700. So in this series, we'll guide you step by step to mastering the brand new DP-700 Fabric Data Engineering certification. Today we'll cover data warehousing in Microsoft Fabric. And if you are looking at the study guide, data warehousing falls under multiple sections. So you'll need to show that you are comfortable with all the study guides which has been given in the Microsoft Learn. So that's what we are here to help you to get understand the study guide and what needs to be done so that you will get success in DP-700. So moving on to the next one. So if you see
So
what
the thing we mention here is just an overview of DP-700. So we'll talk about the fundamental skills that you need to know to pass this certification. It's a different certification, of course, to DP-600, which is the one that covers Fabric more in general. And so 700 looks more specifically at data engineering. And so the skills you need to pass this are similar to what you should expect to need to work as a data engineer in these sort of environments. And importantly, it's rather than separate tools that you would have worked with perhaps in Azure, it's now a case of looking at how do I do this if I'm going to use Fabric as a single offering that I can use to implement all the different things that I'm looking at trying to do. And so the three key areas they get you to look at here are ingesting and transforming data, securing and managing data that's in an analytics solution, and then finally monitoring and optimizing. And so in a little more depth with these, if you look at the implementing and managing analytics solutions, this is giving you examples here of workspace settings and how you do lifecycle management for the data that's part of that, and looking at security and governance, and how you then do things like pipelines to orchestrate getting the data into this. And so if you look at ingesting and transforming the data, this is the patterns that you're going to use. So for example, are we talking about incremental loading, or are we talking about full loads? And are we working with batch data or streaming data? One of the early bits of feedback that I had from a number of people who've been prepping for this certification is they were a little surprised at how much information was in there about real-time intelligence as part of Fabric. So I'd really encourage you, if you're heading towards this exam, to not underestimate the amount of material that it suggests there for real-time intelligence. And take careful note that in this part that's taken from the study guide for this exam, note the percentages in brackets there. So each of those, so 30 to 35%, this exam is fairly balanced across those three topics. And this is the percentage of questions or percentage of points that you can expect to earn in those different areas when taking the exam. And so if you compare this to the previous exam that was there, which is DP-203, as I said, the focus for that one was more on a broad range of services. So it was Synapse and Data Lake and Stream Analytics, Azure Stream Analytics and so on, where DP-700's focused on Fabric and how to do those same sort of things inside Fabric. If you look at 203, we looked at storage and processing pipelines. Predominantly, it looked at data factory pipelines and looked at Synapse pipelines. And of course, now we instead look at pipelines as part of data factory inside Fabric. And so the audience for this is, instead of people who are working across all the different Azure services, although that is really good background for heading towards this work, it's engineers who are transitioning or working with Fabric. And the experience is that instead of having a whole lot of different services that you get to work with, you end up working with a sort of a streamlined single platform for doing the work. But Arul, tell us about Fabric.
Thank you, Greg. So now we understand what is included in DP-700. Now let's dive into the content. We are going to start with bit level of setting. To everyone listening, if this is review for you, please feel free to add your thoughts and experience in the comment section. In this section, we'll discuss what is Fabric and why it is important, and overview of Fabric components and architecture, which includes one like data factory and other experiences which is included in Microsoft Fabric, and also it emphasizes what makes Fabric unique compared to the other platform. So as you see, Microsoft Fabric is a unified data platform for the era of AI, which includes multiple experiences in a single environment, like in a Fabric environment, which includes data factory, data engineering, data warehouse, data science, real-time intelligence, Power BI, and some other experiences which has been rolled out recently. So which all together help a business to get your data in a single place and work with one lake Fabric lake-centric architecture that provides a single integrated environment for data professional and the business to collaborate on data projects. So we have different experiences which helps to uh, enhance your business and take decisions, in which we are going to focus on data warehouse today. So yeah. Next, coming to data engineering, especially we are going to look into data engineering in Fabric, uh, wherein we can explore the key features of data engineering in Fabric that makes it powerful, flexible platform for managing and analyzing your organizational needs. So, in this Microsoft Fabric allows you to create unified lakehouse um, that consolidate all your organizational data. This central repository supports diverse data types and formats, making it easier to manage and analyze data. And also it leverages the power of Spark runtime in Fabric to perform large scale data processing analytics, and Spark distributed computing capabilities enable efficient handling of big data workloads, ensuring high performance and scalability. So it also support variety of authoring tools, allowing to work in the environment you are most comfortable with, whether you are prefer to notebooks, SQL, or visual interfaces. Fabric provides all the flexibility to use your preferred tools for data engineering tasks. It is also integrated into Fabric. The integration of data engineering capabilities within Fabric platform ensures seamless workflows and interoperability with other Fabric services. This unified approach enhances productivity and simplifies the data engineering process. Whoever comes in this particular experiences and using Microsoft Fabric. So now moving on to the next one, data warehousing in Fabric. Greg will walk you through the basics.
Yeah, so look, in this next section, we'll have a look at the key features of this and what really makes it a sort of a powerful platform. And the steps that we're looking at here, or the features overall, just the ability to build a lakehouse that covers all your organizational data, being able to support this with the Spark runtime under the covers and with a nice authoring experience, but again, all completely integrated into Fabric itself. And so if you look at the data warehousing experience, this is just one of the experiences inside Fabric. So the general process here is that we look at ingesting data. So this is sort of moving data that's coming from source systems. There's a number of different ways we can do this, including mirroring, which is part of the Fabric structure as well. We look at how that's stored. And so this is how are we going to store the data in a way that it's suitable for analytics? And the processing step is the transformation that puts the data in a format where we're going to be able to do some analysis over the top of it. And finally, of course, there's the analyzing the data that is part of that. Now, the data warehouse itself is a relational data warehouse. There's been a line of these from SQL Server to the Synapse data warehouse and so on. And now this is the latest iteration of that sort of Synapse, like parallel data warehouse style thing. And so this supports T-SQL language and does many of the things that you'd expect directly with a relational database. And so you are in control with creating tables and loading and transforming. And for a lot of people, doing the transformation of the data using the T-SQL language will actually suit them quite well. It's up to you, though, as to which level you start to use the warehouse at. So some people will have a medallion architecture. They'll have raw data arriving, and that'll be like a bronze layer. Then they'll have a silver layer, which is the cleaned up version of the data. And then eventually they'll have sort of a gold layer above that, which is then used for the analytics. But it's common to use the data warehouse in either the silver and gold, or to just use it in the gold, while there's also the possibility that some people won't use it at all. There's also a series of people who think they could just mirror the data in and then just run analytics straight over the top of that. And look, there's some data where that would make sense. But in the more general case, with any of these sort of BI projects, there's a reason people have built data warehouses in the past. And it's because we need to get the data into the right shape and make it sort of targeted at users, which often the data from source systems is not like that at all. The other thing that happens with it is data is often not very clean. It might be missing, might be duplicated. There's lots of reasons why you might need to do that. Now, the basics of this is it's still centered on a single data lake, and it's the Synapse analytics engine under the covers. It says fully supports T-SQL. Not sure I'd go 100% that far. It has a wide level of support for T-SQL, but not all of the things that you'll find in SQL Server. The files under the covers, we're talking about Parquet file format. So again, open file formats. But if you look at the standard structure for most data warehouses, people doing business intelligence work in mostly in around the Microsoft stack are very, very used to designing structures around star schemas. And so this is where we organize the tables in a data warehouse in a sort of a star structure. The first thing, in this example here, it shows a sale. And so that is the sort of thing that we're analyzing or quantifying. It's usually a table that contains numbers that we often add up or multiply or do things with. It's the fact tables. And so in this case, sale is shown as a fact. And then the dimension tables, the dimensions are things that we analyze the facts by. And so in this case, it's usually the things that come after the word by. So if we say by product or by date or by customer or by store or by employee, that's how we're looking to analyze the data. Now, as well as a star design, what you can have is more of what's called a snowflake design. And the most common scenario for this is that you have a fact table, and then that points out at a dimension, but then the dimension then points to further dimensions. So in this example here, notice that the sale table is pointing at the product. But the product doesn't stop there, right? And so what happens is the product is then in a category and the product is in a supplier. So this forms more of what they consider a snowflake, where the points out on your star end up having additional points surrounding them. And so that still makes sense. I mean, we might want to analyze the sales by that category or by the supplier and so on. Where it becomes a little more interesting is where you start to almost build multiple paths to the same thing. And so note here with sale, it's got which customer did that occur to, and then it's also got which store sold the thing. But then note that both customer and store have a link to a table called geography. This is something we generally try and because if I said, look, I want to analyze this by geography, the question is, what am I really meaning? Do I mean where the customer lives or where the store was and so on? It's not clear as to what you want. And so in most of these sort of designs, there's a concept of sort of a default path for these things. But what's usually better and helps a lot to build better analytics would be, for example, to have a customer geography and a store geography as separate things. And once you get to that point, the question says, why would you even still have a geography table, perhaps? Maybe you just need some of that data to be added to the customer table and to the store table. And so part of the process that we often go through is sort of flattening down these tables. And to give you another example, it's common in transactional systems to have, say, an order header and then a bunch of order details that describe the lines that are on an order. But most of the time, what you're really looking for is a handful of information from the order level and then a bunch of columns out of the order details. And so another approach is that rather than building endless sort of snowflakes or linked facts like that, what we'll often do is a process of flattening, so that maybe we take a few columns out of the order header and we repeat them in the order details, and then we end up with a much simpler thing. The thing you've always got to ask yourself is, what would be simpler for a user who's trying to do analysis on this? And as soon as it's following links to lots of different tables and so on, you've made it too complicated for the user. One other thing I'd throw in, of course, is that in many of these models, there'll be more than one fact table. So this shows one sale on the left with the star, but there could be order or something else as another fact that's being analyzed. But so, Errol, tell us about loading data.
Okay. So once we design the schema, right, the first thing we need to consider after defining the schema, the first thing that we need to consider is loading data. So when it comes to loading data, we need to follow two processes. One is data ingestion processes and the loading strategies, which we are going to follow to load the data. While both processes are part of the ETL, um, in a data warehouse scenario, they usually serve different purposes. So data ingestion and extraction is about moving raw data from various sources into central repository. On the other hand, data loading involves taking transformed or processed data and loading it into the final storage destination for analysis and reporting. So, Fabric data warehouses and lakehouses automatically store their data in one lake using Delta bucket format. So when it comes to data ingestion, the purpose of data ingestion processes is moving data from various sources into central repository. So the process which data ingestion follows is extracts the data from multiple sources such as databases, files, and APIs. Uh, Wherein we have the stage in the data ingestion, we have staging step. In this step, we will define the ETL pipeline. So, for example, ingesting raw sensor data from IoT devices into data lake. And then data loading, we have in this process, we are going to transform the data and process the data and move into the final storage destination. The process which we follow here is like loads the data into data warehouse. So in the data ingestion process, we have four different options to ingest the data into warehouse. We can use Fabric pipelines, we can use Fabric data flows, and crash database querying and copy into command. So each of this process, right, I mean experiences serves its their own purposes. Whoever is flexible with their processes, they can use it. For example, Fabric pipelines, it will be useful whoever is familiar with ADF, and Fabric data flows whoever is not familiar with high level of coding, but still they can transform the data using data flow gen 2, which is visual interface facility, and cross database querying, which will be helpful for SQL people who are familiar with SQL, and copy into command also will be helpful for the people who are is very similar with I mean familiar with SQL. So we can use these steps, I mean these ingestion steps into the warehouse. And next step, moving on to stage, I mean ingestion is staging your data. In this staging your data, you might have to build and work with auxiliary objects involved in a load operations such as tables, stored procedures, and functions. These auxiliary objects are commonly known as staging. So staging objects act as a temporary storage and transformation areas. They can either share resources with the data warehouse or reside in their own storage area. So staging serves as an abstraction layer, simplifying and facilitating the load operation to the final tables in the data warehouse. So it also provides a buffer that can help to minimize the impact of the load operation on the performance of the data warehouse. So this is important in the environment where the data warehouse needs to remain operational and responsive during the data loading processes. So when it comes to data load types, we have two types. One is full initial load and the incremental load. With our there are two types, as you see in the screen. Full load, which is also an ETL process for data warehouse, doesn't it does not always needs to both full and incremental. In some cases, a combination of both methods might be used. The choice between full load and incremental load depends on many factors such as amount of data, the characteristics of the data, and the requirements of the data warehouse. So when it comes to full load, the process of populating the data warehouse for the first time, and all the top tables are truncated and reloaded, and the old data is lost. It may take longer to complete due to the amount of data being handled. But when it comes to incremental load, right, we can append the data to the tables, and it is far faster to update the data. It preserves the history, so it is best for frequent updates. And the full load, right, it will be best for initial load or refresh. So both these methods types have their own advantages and disadvantages, but still it serves a purpose based on the requirements of the data warehouse. So moving on to the next one, loading dimension tables. So when it comes to data warehouse, right, we have two different tables, right, dimension table and fact tables. Having explored the various types of data loads, it is essential to understand the roles of key in ensuring the data integrity and efficient querying within our data warehouse. In a data warehouse, both surrogate keys and business keys are essential for effective data warehousing and data integration, but they serve different purpose. So if you look at the surrogate key, a surrogate key is a system generated identifier that is used to uniquely identify a record in a table within the data warehouse. It has no business meaning, but it's typically an integer or a unique identifier for each row of the data. So surrogate keys are used to maintain consistency and accuracy in the data warehouse, especially when integrating data from multiple sources. So they help you to avoid issues that can arise from changes in the source system, such as using or changing business keys. Business key, when it comes to business key, a business key, also known as a natural key, is an identifier that comes from the source system and has business meaning. It uses to uniquely identify record in the source system. Example of a business key include product codes, customer ID, employee numbers, this and so on. So these are all the examples for business keys. Business keys are important for maintaining traceability between the data warehouse and source system. And also we have different um, and slowly changing dimensions evolve over the time, but at a slow pace and unpredictably. It might take. We have several slowly changing dimensions, right, in our data warehouse, with type 1, type 2 being the most frequently used one. Moving on to the next one, uh, we need to consider how to load the data into the fact tables. As we consider loading the data into dimension table, we need keys, right? So it is typically a standard warehouse load data operation involves loading fact tables after the dimension tables. This ensures that dimensions which refers the facts are already present in the data warehouse. The staged fact data usually includes business keys for the related dimension. So your loading logic must look up the corresponding surrogate keys. When dealing with slowly changing dimensions in the data warehouse, it is crucial to identify the appropriate version of the dimension record to ensure the correct surrogate key is used. In many cases, you will retrieve the latest current version of the dimension. However, sometimes you might need to find the correct dimension record based on the time and time date columns that indicate the period of validity for each version of the dimension. The key challenge in loading fact table is need to look up the correct surrogate keys for each row. So typically the stage data will include all the alternate business or natural key, but you need to use the surrogate key in the fact table so that each row is related to the current instance of the each dimension for the time at which the fact occurred. So yeah, that is how we need to load the fact tables. We need to load the fact data once the dimension data is loaded, so that it will be easy for creating a reference key which is referred to the dimension table. Moving on to the next one, we need to use pipelines to load the data warehouse. If you are using pipelines, pipelines offers many different activities for orchestrating data movement. However, the most common uses for loading data into a warehouse will be yet copy data and possibly scheduling parameters and delete data depending on the load time. So the pipelining pipelining will be the process to load data into the warehouse, wherein we can use different orchestrate activities. As mentioned in the slide, we can use copy data, schedule, and parameters. We can even delete data option in the pipelining. So we have one more type to load, one more option to load the data into warehouses using T-SQL copy statement, where copy statement serves as the main method for importing data into warehouse. It facilitates efficient data ingestion from external Azure storage account. It offers allowing you to specify the format of the source file and this designate a location for storing rows that are rejected during the import process. So the option to store rejected rows separately is useful for data cleaning and quality control. So it allows you to easily identify and investigating any issues with the data that weren't successfully imported. So we can use T-SQL to load the data from uh, different places, like from Azure or anything which is using SQL languages, right? We can use T-SQL to load the data from different places. Moving on to the next one, load from other fabric items combined into one warehouse. So as you see in the previous slide, we can load data using SQL statement. Here we can load data from other fabric items. So as in the title mentioned, you can load data from other workspace, such as warehouses in other workspace can serve the data to or other workspaces like a crash workspaces or crash database. We can load the data from crash workspaces into different workspaces. So for example, if you have two workspaces and you need to load the data from workspace 1 to workspace 2, you can load the data from workspace 1 to workspace 2. So wherein you can use SQL statement and insert select statement for creating the table. You can use create table statement, or to insert the data you can use insert and select. So various different options uh, to query or load the data from different workspaces. Generally, we call it as cross database query, which contains three-part naming like a database and then workspace name and then the uh, table that we are going to load the data. So, which we can refer from the documentation. So, yeah, next one will be monitoring a Fabric data warehouse that Greg will walk us through. Yeah, Greg, over to you.
Okay, yeah, look, just actually before we head a little further, there's just a couple of things I think you need to think about if you're going to do this exam. In particular, make sure you have a good understanding of slowly changing dimensions. When Kimball did the description of these, he sort of gave them numbers. There are a whole lot of numbers nowadays, but make sure you know your way around type 0, type 1, type 2, and type 3. Effectively, type 0 says, look, the data can't change. And so if you have some data that you've decided is meant to be static and can't change, the question is, what happens when a change arrives? Now, most of the time, I would think that there's very little data that's in that category. But if you do get a change to data that you've decided can't change, that probably needs to throw an error at that point. A more common thing is a type 1 change. And a type 1 change says we just overwrite whatever happened to be there before. And now, why this is a problem is for historical reporting. Imagine I have customers who are allocated into sales territories or something like that, and I analyze their sales by territory. But then I go and rearrange all the territories so that customers are now in different territories to what they were before. So then the question is, what happens when I report on last year's data? So has all of the data suddenly made its way into the new territories? Or does it still show the same as what a report would have shown back a year ago? Right? And this is where type 2 changes come in. So type 2 says, look, every time there's a change to dimension rows in whatever aspect of it we think is important, what we're going to do is go and create another dimension row for the same dimension item or the same entity, and we're going to have the new details. So the beauty of that is if I look at the current structure, all the things are in the new territories. But if I look at the report for last year's data, things are still in the territories where they were. Now, sometimes you want to track this stuff. Sometimes you don't want to do that. So for example, if I have a product, I might decide that if the color changes, then I actually don't care. But if the price changes, I really do care that it's different. I would suggest that probably with a color, you'd probably want to know that that changed too. But anyway, there can be aspects of the product that really cause you not to want to create a new row. Now, the final one I mention is just type 3. And type 3 says we store in the row details about what the historical value was. I'm really not a fan of these. But imagine that you have a thing that says a sales territory for a customer, but you could also have a thing that said previous sales territory or things like that. So inside the customer, you could store details of where it used to be. That's much, much harder to use in any sort of sensible way. And so look, they're the main ones that you need to concern yourself with. And in particular, for something like type 2, you need to say, how is it going to know which row a fact is attached to? And so some methods I see people do, like it was saying on the slide, is current. And so they always, when they get a new fact in, just find the most current dimension row. But I'm not a fan of that, because that depends on everything being loaded in exactly the right order and nothing ever being missed. Where if I go back and find for this fact that occurred on a particular date, go and look up the values of what was the dimension value on that date, that's more how I'd often look it up. And so what you'll have in a type 2 is you'll have extra columns that say that you could have is current, but more commonly you'd say something like, what's the start date, what's the end date, and so on, for those particular values. And whereas in a type 3, you're going to have an extra column for each of the attributes that you want to pick up a change. So just make sure you've got your head around how those different things work. And so look, monitoring your data warehouse is essential for optimizing performance, making sure your resources work properly, making sure your data quality and integrity is happening, and that things aren't falling over mid-process and so on. But importantly as well, keeping an eye on the sort of capacity units that you're using while doing the processing. And so the cost when you're using Fabric is based on what's called capacity units. And whenever you're doing things, you're sort of using up capacity units, and that's the thing your organization's being billed for. So you need to watch the usage of those. And so in the case of a data warehouse, when you're doing data reads, data writes, things like that, or file operations in OneLake storage, this is going to be consuming capacity units. And so to give you a view of that, the Microsoft Fabric Capacity Metrics app is an app that lets you help work out what's going on. Now, it has a number of things in relation to the warehouse, and there are 3 areas where things turn up as part of the monitoring. So you've got a warehouse query total or category, and that's a compute charge for all the user-generated and system-generated T-SQL statements within a warehouse. So keep in mind, it's not just the user ones, it's where the system has decided to execute a T-SQL query for some reason. You've got the SQL Analytics endpoint query, so where somebody has, or something has connected to the SQL Analytics endpoint and run a query there. And you've also got a compute charge for read and write in one lake. And so you'll see one lake compute as another category as part of that. But a final thing is that each of these operations is sort of categorized or classified as being interactive or being background, and that's shown by the color of in the graph being displayed. Now, to monitor the current activity, you can query what's going on in the warehouse itself with dynamic management views, DMVs, that are provided to help monitor this. Dynamic management views first appeared in SQL Server back in 2005, and the idea was to allow you to have a way of querying what's going on inside the server without having to literally get inside the server with your own code somehow. And so that's what the DMVs are. The ones that are relevant here, we've got sys.dm exec connections, and that has information about where you're connected from. It's got things like your IP address. It's got a variety of stuff like that, the host IP address. DM exec sessions has, if you're authenticated in a session, it's got details about who you are as a user, kind of who you're acting as an identity, and so on. And it also has counts about what you've used in terms of reads and writes and so on. Where every session that's logged on and whether it's doing anything or not, has an entry in DM exec sessions. Where DM exec requests only has rows in there for things that are currently running. And so a request is connected to a session. You'll find there's a neat hierarchy for these. So for example, the DM exec sessions view has a session ID. The connections also has a session ID, and the requests has a session ID. So it shows you which session they're currently connected to. Now, that's okay for things that are running right now, but what about things that have previously run? And so for historical queries, there's a query insights feature that gives you historical aggregated info about queries that have been run. And so rather than sys dot something, these are sitting in query insights exec requests history. So that's details of each completed SQL query. We've got long running queries, so things that have taken long query times to execute, and frequently run queries, details of queries that are just run all the time. I'd suggest a lot of people spend time looking at the heaviest queries, and they're worried about things that take a long time to run and so on. Do not underestimate the value of checking for frequently run queries. I often see systems where the same queries are just run endlessly, and there's no logical reason as to why that occurs, but the noise is not helpful to the system. But anyway, so Harold, tell us about securing these.
Yeah. So to secure a fabric data warehouse, right? It's a very crucial part to protect the sensitive data, to ensure compliance with regulatory requirements, and to maintain the integrity and the availability of your data assets. So it's very important. And for implementing the robust security measures, which involves a multi-layered approach that includes access control, encryption, network security, and monitoring. So by leveraging these features, such as role-based access control (RBAC), with data encryption at rest and in transit, virtual network integration and continuous monitoring, organization, and some other things, right? Data breaches and other security threats. So we need to secure the database from all the security threats. So additionally, adhering to best practices, regularly reviewing security policy and configuration will help maintain a secure and resilient data warehouse environments. So moving on to fabric security, starts at workspace level. So, yeah, so for many of you who works with Power BI already knows what is workspace level roles, but Data engineers who are often well versed in SQL engine and adapt are using SQL will find warehouse and Fabric will be very easy to use. This is because warehouses are powered by the same SQL engine that they are familiar with, which enables them to perform complex queries and data manipulation. This SQL engine is having the wide range of security features, which further allows for sophisticated security mechanism at the warehouse level. So, in a Fabric environment, right, we have mm, different level of access. When it comes to workspace level access, which is having admin level access, member level access, contributor and viewer level access, each level of access having their own visibility to the users. For example, admin might be having the access to all the items in the workspace. Member might be restricted to some other level of items, and contributed which might be restricted to some other level of items. So there are different level of access roles which we can provide in workspace levels. uh, then moving on to the item level access permission, item level permissions, individual workspaces or individual warehouses can have item permissions assigned directly to them for their accessibility. The main intent behind assigning such permissions is to facilitate the sharing of the workspace for the downstream use. So this is item permissions for in a workspace. Each any user can admin can give access to user based on the item level. So it is not at workspace level, but inside the data warehouse they can be provided with item level access as well. So next, moving on to the data protection security. For more precise control, you can use T-SQL to grant specific permission for the users. Barrow support a range of data protection features that enable administrations to seal sensitive data from unauthorized access. This includes object level security for database objects, column level security for table columns, and row level security for table rows using where clause filters, and dynamic data masking to obscure sensitive data like email addresses and some other important data. These features ensure data protection across warehouses and SQL analytics endpoints without necessitating changes to applications. So moving on to the next one, we have dynamic data masking (DDM), which is a security feature that limits data to exposure to non-privileged user by obscuring sensitive information. Dynamic data masking offers several key benefits that enhance the security, manageability of your data, and some more steps. One of the primary advantages it is real-time masking feature. When querying sensitive data, DDM applies dynamic masking to it in real time. This process means the actual data is never exposed to unauthorized users, thus enhancing the security of your data. Furthermore, adding on to that, DDM is straightforward to implement. It doesn't require complex coding, making it accessible for users of all skills. Uh, One more benefit of DDM is that the data in the database is not changed when DDM is applied. Instead that masking rules are applied to the query results. This benefit means that the actual data remains intact and secure, while non-privileged users only see the masked version of data. So we have one more level of security, which is a row level security in Fabric data warehouse. This feature provides a granular control over the access to the rows in a table based on group membership for execution context. For example, in an e-commerce platform, you can ensure that the sellers only have access to order rows. Whatever rows which is related to orders that are uh, related to their own products. This way, each seller can manage their orders independently while maintaining the privacy of the other seller orders information. If you have experience in SQL Server, you find that row-level security shares similar characteristics and features. So if you're familiar with Power BI as well, you might having the same features to restrict a row from the particular set of users to not expose the data. So similar functionality will be applied in data warehouse as well. So That's how RLS will be working in data warehouse. Yeah, so Greg will talk about the practical tips for excellent success of DP-700.
Yeah, so a thing that we need to stress a little bit, of course, are things in this area that are going to help you prepare for the exam. And so while there are lots of sessions I could run on just overall exam technique and how you work with Microsoft exams, there's a few things specifically about DP-700 that you need to get your head around. The first thing I cannot stress enough is the hands-on practice. I've often seen comments from people with exams like this, and they've struggled, and then they come out and they say, "Oh, you really probably need hands-on practice to be able to pass this exam." And the answer is yes, you do, right? So it's so important that you get actual experience in using the tooling. Beautiful thing is that, of course, there are the trial subscriptions for Fabric. You can spin one of those up. If you don't have an appropriate ID, you could even spin up an office trial or something like that to get an ID, and then apply and get a Fabric trial, and just try these things. The study guides are incredibly useful because keep in mind, this is what the exam questions are built of. So you need to take the study guide, look at every single topic that it mentions in that guide, and ask yourself critically, do I know about this thing? You know, and if you don't, go and find out about it before you go and do the exam. So really, really important to have that. There's a bunch of resources, of course, like these sessions and so on. There's a practice test on Learn, which is more sort of like sandbox material a bit in terms of getting used to, at the moment, what these exams are like. But there's a full Microsoft Learn course, which is now has pretty good coverage of all of the topics associated with this. And of course, there are a whole lot of sample projects you can use as starting points. But AKAMS Fabric Trial. And so, as I said, keep in mind this is session 4 of 7. And so next session that's coming along is really, really interesting. And it's on CI/CD, or continuous integration, continuous deployment, and monitoring and security. And this is where we look at things like how GitHub can be integrated in conjunction with Fabric, or Git-related source control. I mentioned earlier there's the exam discount, so AKAMS GC DP-700. So if you're going to tackle this, it'd be really, really good for you to get a discount, so that that makes it cheaper for you to do. And of course, if you're going to have any chance of getting to the community conference, then you want to pick up the MS Cust $150 discount, but AKAMS FabCon 25 DP-700. I also at the beginning mentioned the Power BI Data Viz World Championships. You can enroll in that at the moment, and then build out and attempt the challenges and submit those. And the winners for that will be announced at the Fabric conference. And so that's time for us just to see if there are any other questions. I know the moderators will have been doing a fabulous job there. You'll find resources at AKAMS I Am Ready DP-700 Prepare, or there's also the forum for DP-700. But what have we got? So Mitchell, so we have a DW system currently run on premises with SQL Server 2019 built using SSIS. What are the major benefits of moving it to Fabric considering license cost? The main thing is to have integrated tooling for all of this. You need to decide with the SQL Server work that you're doing whether you'll still keep that on premises or not and connect to it via a gateway, or whether you'll be picking that up and moving it. Now, it could move into any one of the Azure SQL options. Chances are very high that connecting from Fabric to one of those will probably give you a better outcome. We used to heavily use integration services. I find now I still use that periodically, but it's more where we have clients who just absolutely do not have any desire to have their data not on premises. And so we may even use analysis services or things like that. But most clients that we're working with now have picked their data up and have started to all move that cloud-based. I won't pretend that that's trivial. With any of the systems that are currently being used on premises, there's usually a bit of work in terms of the migration. And the more you're heavily hitting something like an on-premises SQL Server, the more work's involved in that. But in terms of replacing integration services, there are two approaches for that. One is in Data Factory, not yet the Fabric one. What you can do in Azure Data Factory is run an integration services runtime and execute the SSIS packages there. But even with ADF, we found that we have redeveloped the things, and that's actually kept our costs down significantly by doing that. I only have two groups of customers who complain about the cost of Azure Data Factory, and that's people who use the SSIS runtime or people who have been using data flows heavily. And we tend, in the design of we tend to avoid both. There's also, what's the difference between Fabric pipelines and copy into? The copy into is being used in Fabric pipelines. Yeah, copy into is where we're using a T-SQL command to copy the data from somewhere, usually from a data lake, and bring that directly into tables inside SQL, or in this case, inside the warehouse. Whereas a pipeline is basically a set of activities that can run and do that. And it does include things like a copy job for copying the data. Is there anything you want to throw into that, Errol?
Okay, I think that's good. I see one more query which is repeated again and again. Where can we get practice if I'm a newcomer? So for that, right, if you go to the Microsoft exam section where you can find the applied skills. In Fabric, right, we have 5 applied skills which is related to Fabric. Out of four, we have implemented data warehouse and implemented lakehouse and implement real-time intelligence, which is related to DP-700, which I found helpful while preparing for the exam. So whoever is trying to uh, preparing for the exam, they can go and see whether the applied skills would be suitable for them. Because I found that helpful for me to prepare for the exams. So they can go and pick up the applied skills like implemented data warehouse or implemented real-time intelligence things. They can prepare by using the virtual environment which has been provided by Microsoft.
Awesome. Well, I think we're done there. Thank you again, everyone, for attending. It's been a pleasure to be involved today.
Yeah, thank you, everyone.